Hey, we are learning something right now that is called function notation. It is a fancy way of doing what we've always been doing in algebra class, where we just talk about an equation. Basically, function notation is a fancy way of saying why. If you take a look at the two equations that I have up here on the screen, we have one that is labeled f of x. It's pronounced f of x or g of x or k of x or h of x. And basically they just are in they're in the place of y. The usefulness of this is that you can have a problem now that has more than one equation to it, and you can then know what equation you're talking about if you want to talk about one specifically instead of both of them. I can say, hey, I want to talk about g of x, and you would know that I'm talking about the line instead of the quadratic. So let's take a look at what these expressions look like. If I were to take a look at the first problem I have on here, it says f of 2. If you look at what you have a 2 right in where you have, or where the x normally would take place. So what this equation is saying is let's put 2 into the function f and in for x and find out what we get. It's another way of saying plug in x and find out the y. So I have 0.5 times 2 squared minus 6 times 2 plus 8. And you're essentially finding the y value. 1/2 times 4 is 2 minus 12 plus 8. We're going to get negative 2. So you're just finding the y value for that particular x. What's nice about this is you take a look at the next problem and you see g of 0. That means we are going to plug 0 into the equation called g instead of the equation called f. And it just gives us a better way of labeling equations. You'll start to see problems where you have more than one equation in each problem, and this helps us kind of name them a little bit better. So 4 times 0 is 0 minus 3. You're going to get negative 3. We can be a little bit, I mean, you can do this with fractions. It doesn't have to be whole numbers. It's just, hey, let's find what happens when I plug in 1/2 for x into a problem. What's the y value that you get out? When I plug all these in, you're going to get 1/8 minus 3 plus 8. Which is going to end up being 5 1/8. It's fine to leave it as an improper fraction. Be careful when you're substituting in your negatives. Down here, we're going to put 4 into the f of x equation. So we're going to have 1/2. Make sure you're adding in parentheses so that you know to properly square a negative 4. When I square negative 4, I'm going to get a positive 16, but 16 times 1/2 is 8. Negative 6 times negative 4 is positive 24. So we're going to end up with 8 and 8 is 16 plus 24 is 40. G to the 1/2 means we're plugging in 1/2 into the g of x equation. So we're plugging that into the linear equation. 4 times 1/2 is 2 minus 3. We're going to get negative 1. You don't always have to plug in a number. If you look at this next problem, you're going to see a W. That just means every place that you see an X in that problem, you're going to put a W. Basically just switches over the variables in that problem. So now we would just have 4W minus 3. Now, there's two ways or two types of problems that could be asked if you're just talking about scientific notation. And you have the first way that I just explained right there. And then we have the second way, which would be the problem that reads as on that's what's on the board. What would this mean if I'm asking if f of x is equal to 3x plus 6? So I'm redefining what f of x is. I want to know when f of x is equal to 0. If you notice, it's not the number is not where x is, the number is now where we're equal to. If you think about what that's always meant in math class, that means that you're trying to figure out when y is equal to 0. Notice x is still left in the problem, so when y is equal to 0, what is the x value that gives us that? So we're going to set the equation that I have right here for f of x equal to 0. And we're going to start solving for x like we would normally solve any equation. And what that means is that when x is -2 in this equation, f of x is going to equal 0.